check. You're on. You're on. We will be starting soon.
Hello, hello. Should I speak now?
Dr. Thomas, am I audible? This is Nikhil Pal here.
Yes, sir. You're
Oh,
audible.
okay, thank you.
We'll be starting soon, sir. We're just waiting for more people to come. Hello, 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 hello.
Check. Yeah. I hope I'm audible. I'm audible to you guys, right? Okay. Uh, and sir, am I audible, Nikhil sir?
Yes, you are audible perfectly.
Sir, could you just say a few more words? We're just checking the audio setup here.
Yeah, I could hear you clearly. I hope you can also hear me okay.
Yeah, sir. Yeah. I think we can get started then, sir. Uh, yeah, I think Siddharth can come and get us started.
Check. Uh, Good evening, everyone. Welcome to the inaugural event of the Computational Intelligence Society at the IEEE NITK student branch. We are thrilled to have you all here attending the workshop on GANs, one of the most exciting and rapidly evolving fields of computational intelligence. As you may know, the CIS student chapter was established last month, and it primarily focuses on advancing the knowledge and skills of its members, primarily in the fields of artificial intelligence. This new branch provides a platform for students to exchange ideas, collaborate, and contribute in the field of computational intelligence. We have several more interesting events planned as a society in the upcoming months. So we hope that this workshop proves to be a valuable learning opportunity for everyone present here, and you find this both engaging and informative. I would like to thank both of our speakers for making it to the event, and thank you all for being here, and hope you have a wonderful experience.
So the first speaker for today is Dr. Megha P. Arakiri. She is the current chair of the Computational Intelligence Society, Bangalore section, and is an associate professor in the Information Science and Engineering Department at MS Ramaya Institute of Technology, Bangalore. Dr. Megha P. Arakari completed her PhD from NITK during the year 2013. She has more than 16 years of teaching and research experience and has around 50 research publications in reputed international conferences and journals. Her areas of interest are image processing, pattern recognition, machine learning, human computer interaction, um, information retrieval, and big data analytics. And she has worked on funded and consultancy projects related to smart agriculture, computer aided diagnosis, assistive technologies, non destructive quality evaluation, and other projects. Over to you.
Thank you for the introduction. Can you hear me? Hello,
Yes, ma'am.
is it audible?
Yeah, ma'am, you can go ahead.
Yes. I'll just share my screen. Can you see the slides?
Yes, ma'am, it's visible.
Okay. So if any audio problems, please let me know. Hello.
Yes, ma'am.
Okay. So thanks for the introduction, and I first of all congratulate you all, the student team, as well as Dr. Anappa sir and his team for initiating this IEEE CIS student branch, which is the very important one where lot of activities are going on in the Bangalore section, and a lot of students are involved in this trending stream of IEEE. So now I'm going to give you as a myself as introduced. I'm Dr. Megha, current chair of IEEE CS Bangalore section, and I'm also working as associate professor in MS Ramaya Institute of Technology. And before that, I'm alumni of this NITK Suratkal, where I did my PhD in information technology department from 2010 to 2013, where very collaborative as well as a quality research work was carried out with the guidance of Dr. Ramohan Reddy of Information Technology Department. So that is one more thing where I'm happy to involve in this platform or the forum where, and being a chair of IEEE, I am able to inaugurate this event. So I'll not take much of your time. As a chair of IEEE Computational Intelligence Society, I just want to tell you what activities take place in this society and how the students are involved and what applications or the fundings you can go for with respect to your projects. Uh, so as you know, IEEE is the Institute of Electrical and Electronics Engineers. It's a world's largest technical global means platform, professional forum where many engineers can involve to advance the technology for the humanity. And under that, you have several societies like Computational Intelligence Society, Computer Society, Signal Processing. So various societies are there. So based on the streams, what matches to the students' fields of that organization, the society can be opened or initiated in that college. So accordingly, since you have started Computational Intelligence Society, so the code for this, because for further communication, you must know the code, that is CH10598 is your local code, which is associated with the Bangalore section. And CIS 11 is the global code that is the recognition for our Computational Intelligence Society. So this computational intelligence, CIS focuses on the computational paradigms that are, there are three main pillars for CIS, that is neural network, fuzzy systems, and evolutionary computation to build the intelligent systems. So that is what is about CIS focuses on the technologies. And being part of this student branch, what the opportunities or the benefits the students get. So they get a platform to learn the new technologies or what is going on in the industry, to understand the current trends. And you also get an opportunity to interact with the industry people, academicians, as well as the other students who are doing certain innovations in different organizations. Not only locally, throughout the world, you can have opportunity to interact with them, collaboratively work on certain projects and contribute your technological innovation for the betterment of humanity. And also you can get connected to various IEEE sections, like we have several subsections, like Mangalore section is there, Mysore subsection is there, Bangalore section is there. You can get connected, participate or volunteer various conferences, workshops, and distinguished lectures. So you can organize many events not only in your college, but you can collaboratively work in different international conferences also in organizing them. And it offers resources to acquire new skills, like it gives you access to many magazines as well as the journals, so that you will get to know what are the research trends, what is happening in the field of computational intelligence, so that you will be able to innovate certain things in the technology. And also, it's not only volunteering or learning. In the process, you can even go for, there are hackathons which are specially conducted from IEEE, and where only the IEEE members are allowed in certain things to apply for the proposals. You should be IEEE member. So that's a good opportunity where a lot of review goes on. You will get the reviews feedback from the eminent persons, so you get to know like feedback on your projects. And if you have done certain innovations, some contributions to the technical field, then you will be recognized and also awarded for the exceptional works. So that is the opportunities. And as a student branch, what all activities you can conduct? I have listed here some of the things, like workshops or the guest lectures, distinguished guest lectures, training programs for the students on the latest technology trends, and hackathon to provide them some competitive platforms and motivate the students in technological contributions. It's not only about the technology within the college, the development within the college, or working on the projects only within the college. You can even do the outreach programs. If your student branch has to get a lot of visibility and lot of interactions with the outside world, then the outreach programs are important. So you should learn in like whatever you learn in your classrooms, the technological concepts, that you must know how, apply them, how to apply them to solve the societal problems, and develop certain new devices or equipments or the technology in order to solve the issues in the society. So that will be your contribution as an engineer to the society. You can even go to the schools, develop the curriculum, some government schools or very rural schools, and you can develop the curriculum for them, because they may not be knowing about the computer, even the usage of the computer. And you can teach them certain basics of computing, as well as develop the curriculum for computational intelligence, so that you can even train the students as well as the teachers. The faculty as well as the students of this student branch can take up such initiatives of the outreach programs. And also you can have several industry interactions, invite eminent persons from the industry to give the training or the workshops on the latest technology topics. So these are some of the events, like I'm giving you some of the our section events that were conducted. This was conducted the hackathon in MS Ramaya Institute of Technology, where some many members participated in that. And also these are from different student chapters in IEEE CIS. You can see there are high school outreach programs where they went to the government schools and delivered the lectures on the computational intelligence. And we have invited several industry people for the training programs. So these are some of the events that happened in the past. And our current student branches, like currently we had fifth, and now the add-on to that is from the NIT Surathkal. So totally we have six student branches on date in IEEE CIS, and the total number of members is 189. But since this is a March, I think still there will be an increase in the number of members, so that you can motivate your students and as well as other colleagues. We have this 189 is total on the student as well as professional membership. So you can, if you start working actively, start conducting more and more events, then the others will also understand the benefit of that. You can form a bigger community who are working towards the advancement of computational intelligence. And then, so coming to because you are initiating this chapter, more students are involved in it. So I just want to tell you like what the computational intelligence focuses on, so that your projects or your workshops or your training programs can be towards this. So the computational intelligence, before going to the computational intelligence, you must understand what is artificial intelligence, as this is a buzzing word, the current trend in the industry. So it is nothing but the simulation of the human behavior in the machines. So our machines, like you take the mobile phones or our laptops or desktops, they all are not natural, they are artificial. So we need to introduce the intelligence into them to make it as artificial intelligence, so that the machines can have the perception of the things, understand the things, have the ability to think over the data that is provided to it, learn from the data, as well as it will be able to make the decision based on the data. So just like how the human behaves intelligently, in the same way whatever we are able to do, so the same way the machines must be able to do. In that way, you are going to introduce the intelligence into the machines. So that is all nothing but it's a world of automation where everything is getting automated. You can see in the healthcare or in the agriculture, in the transportation, everything is getting automated. That is because of this artificial intelligence technology. So the applications, it has wide range of applications starting from the healthcare or surveillance system, transportations. I just put on some images here so that you can understand. Autonomous vehicles is that is one of the greatest application, where the driverless cars are there, which can recognize the lanes, the obstacles, and the proper routes to drive the vehicle. And in the agriculture, now the technology is even coming into the agriculture, where a farmer can sit at home and analyze what is happening in his field, like understand the soil moisture. He can bring in the smart irrigation by automatically understanding the requirement of the water for the plants. The right amount of water can be supplied to the fields, and even the drones and the robots can be used to cover the large acres of land, where they can be used to identify the what kind of diseases are affecting, and accordingly spray the pesticide, not randomly spraying the pesticide. Like if you randomly spray the pesticide, then it can affect the health of the human beings as well as of the plants, and it will degrade the environment around it as well as the soil quality. So based on how much field is affected, based on that, the right amount of pesticide specific to the site has to be sprayed by those drones or the robots. And that is where your artificial intelligence comes. And in the healthcare, the most what is going on nowadays is the software that can analyze the lab reports or your CT or MRI scans. So what we call them as computer aided diagnosis systems. So they can analyze the disease and provide assistance to the radiologist in analyzing the disease based on the data what is provided to them. And you have remote patient monitoring system in order to support the rural people, as well as telemedicine. So many applications in the healthcare also. And of course in the space exploration, to understand the weather conditions as well as the soil quality or any other understanding of the environment around. And you can see nowadays the security cameras are installed everywhere. So the security camera is not just, if you want to bring in the intelligence into that, it's not just taking the videos. Those videos have to be analyzed and identify if any unauthenticated person is entering the house, or is there any movement of the person is there in the surrounding environment, in means in its visibility. So if it is able to detect that and send the alarm to the owner, then it is the intelligence that is what is brought into the surveillance camera, rather than just being a camera just recording those videos. So on the roads, if it is installed, it can identify the buildings, different objects, and if there is any unattended bag which is lying there for a long duration of time, of course, then the alarm must be sent about it to the respective people. So that is what was the applications of artificial intelligence. Then comes the computational intelligence. So if the machine has to mimic the human behavior, if the machine has to act intelligently, think, and able to make the decisions, then you need to develop certain algorithms, introduce the methods into the system so that it can behave intelligently. So that is what we call it as computational intelligence, which focuses on the methods, algorithm, and the implementations to bringing that intelligence into the systems. So most of these computational intelligence paradigms, they are based on nature or bio-inspired computing. You must have already come across in your curriculum about bio-inspired computing. So let's look at what are they. So these are, as I already told you, these are the three main pillars of computational intelligence to build in the intelligence systems. That is artificial neural network, fuzzy logic, and evolutionary computing. So as the artificial neural network, it is also the a natural or bio-inspired kind of computing. Like as we know, the human brain consists of various neurons, where it takes the input from various sensory organs like touch, smell, and what you can through your vision. It takes so many inputs, process those neurons. Several interconnected neurons are there. Those inputs will be processed and a decision will be taken. So that is how our brain works on in getting the input and producing the output, and accordingly our body takes those actions, makes certain actions based on what the brain uh, uh, takes the decisions. So based on this concept, the neural networks are built in. Very again, here you have a various processing inputs. I have shown it on the right side, where different inputs can be passed on to the processing elements. So these weighted inputs, we take the summation of the product of these weighted inputs, and then based on the output, the whatever is the result will be given as y1, y2, or yn. So the class what it belongs to, this x1, x2, xn can be the features of the object. Based on the features of the object, it can tell you to which category that object belongs to. So that is artificial neural network concept. Almost this concept is there in your most of the curriculum in the machine learning, where you study it under supervised learning. So that is what I was talking about, the supervised learning. So when you want the machine to be work on the artificial neural network, then you, since it is a supervised learning, you need to train the system with lot of images. Suppose if the machine has to recognize that this is, I have given here a very simple example, like if it has to detect that this is a cat, then you have to input the features of the cat, like the cat has 2 ears and what kind of fur it has, the tail, number of legs. For example, these are the features on what we recognize it. So accordingly, based on the image, you need to extract all those features and feed it to the machine learning model, so that it gets trained to recognize that object as a cat. If a picture is given, you can see on the right hand side, you have the picture where humans are there as well as the cat is there. But if this picture is given as the input to the machine learning model, then it can, once it is trained, it can recognize where is the cat in the picture. So the next computational paradigm is evolutionary computing. So evolutionary computation, it is based on the Darwin's theory. So that is Darwin's theory, it is survival of the fittest. So that is nothing but biological evolution. So that which takes on with the genetical inheritance and leads to trying to survive the individual. So that is the evolutionary computation. So one of the example for that is what is popularly used in the current research in computational intelligence is the genetic algorithms. So this I have given you the basic idea of the genetic algorithms, but there are various researchers which have who have come up with various modifications to this algorithm. Like it takes the initial population, calculates the fitness, and then you have selection and mutation, And then depending on the stopping criteria, you will move on to evaluate it or to arrive at it optimal solution. So those are the genetic algorithms. So then the last computational paradigm is fuzzy logic, where the algorithms can work with the uncertain data. So uncertain data, one simple example to tell you, if I say the sky is bright, bright means to what level it is. The brightness, if I say or if somebody is tall, tall means if the person is of 5, you consider it as tall, or 5.3, you consider it as tall. What it is? Tall, how do you define it? Or the sky is bright, how do you define it? This is all uncertain data. It is subjective, right? Somebody may say that the sky is bright, somebody may say that no, it's not bright. So it is uncertain data. So if such data is there, how do you deal with such fuzzy data? What are the techniques to handle such fuzzy data? So here you can't take a crisp decision like yes or no, or 0 or 1. So your membership value for the data lies between 0 to 1. So that is the fuzzy membership, what you call. So there are several techniques, fuzzy algorithms to deal with such kind of data and arrive at a decision. So that is how about the computational intelligence paradigms working on artificial neural network and evolutionary computing and genetic algorithm. So what is now the current trend is to work with more computational power, handling large amount of data, and to design the better algorithms with a good time complexity and space complexity, and which can handle a lot of data and arrive at a decision in a short amount of time. So that you build in using all these technologies, you have to innovate in that technology, bring in some new devices or the technology, so that there is a market trend for that and gets its importance. So that is about the computational intelligence, what I wanted to tell you, like for you students of the student branch, so that you will get to know like what is your society about and on what you need to work on. So that, and other opportunities, like in my first slide or in the second slide, I told you what are the benefits. In addition to that, what you can look for, the websites of the IEEE CIS, there will be call for the projects, project competition will be there. Your project, student projects will be funded by IEEE CIS. You can make use of that opportunity. They will even fund you for the industry interactions, outreach programs, as well as for your, if you want to develop any new kind of devices, so that can be done. So you will have even the, you can compete at the global level, not just at the Bangalore section level. I'm also a member of the educational activities board at the, this is a global committee, so I am a member of that, where many students apply for the projects, and from various part of the world about their engineering projects. You must have heard of EPICS, that is engineering projects and community service. So that is the platform where we receive several projects for funding. So you can also apply, and if you come up with the innovations, you have a platform to in, like whatever you have learned, you have the opportunity to apply on that. So if you come up with the new things, you can publish. So there are various conferences which are supported by IEEE, like now the recent one, we what we have is in the August we have IEEE Connect, which will be held in MS Ramaiah Institute of Technology, Bangalore. So you can apply whenever you make innovations, you will come up with a new idea. You can write papers and apply to those conferences, or volunteer in organizing those conferences. So all those are the benefits for the students. So with this benefits, I want to come to the end of this talk. So thank you one and all. Thank you to the IEEE team of NIT, and also giving me the opportunity to be part of this. So the earlier the students had contacted me some 3 4 months back, they had contacted me asking for like how to initiate the student branch for filing the petition. some guidelines were given, and now I'm happy that it is the branch has come up now. So you can start the activities, and if you have any doubts, any clarification, and any support needed from the Bangalore section, you can always contact me. So that is what. Thank you, one and all.
Yeah, thank you so much, ma'am, for that informative session on what computational intelligence is and the opportunities and events that are available for CIS members. So the next speaker for today is Professor Nikhil R. Pal. He is a professor in the Electronics and Communication Sciences Unit and is the head of the Center for Artificial Intelligence and Machine Learning of the Indian Statistical Institute. His current research interests include brain science, computational intelligence, machine learning, and data mining. He is a recipient of the 2015 IEEE Computational Intelligence Society Fuzzy Systems Pioneer Award, and he has given many plenary keynote speeches in different premier international conferences in the area of computational intelligence. And he has served as the general chair, program chair, and co-program chair of several conferences. And he is a distinguished lecturer of the IEEE CIS and was a member of the administrative committee of the IEEE CIS. And he has served as vice president for publications of the IEEE CIS and the president of IEEE CIS. A warm welcome to you, sir.
Uh, Thank you very much. Am I audible there?
One second.
Ma'am, am I audible?
Yes, sir.
Unfortunately, suddenly my video is not working. It says that video is cannot find your camera, but anyway, the voice is audible, so that's at least a good thing. So good evening, everybody. Let me first share my screen. Hope that works okay. I share my entire screen. So is my screen visible? Oops.
Yes, sir.
But I cannot see it. Is it visible now? Hello? Hello?
It's visible.
Okay, thank you very much.
Visible, sir.
Okay. Dr. Thomas, you have my mobile number. In case of any audio problem, please do call me without any hesitation. So once again, good evening. I consider myself a volunteer of IEEE Computational Intelligence Society. And as a volunteer, it's indeed a great pleasure and honor for me to be a part of this inaugural program of the IEEE CIS Student Branch Chapter. And I'm thankful to the organizers for inviting me. I'm supposed to talk for about 30 minutes, maybe a little less than that. So I thought of dividing my talk into two parts. First part is related to CI, CIS, etc. But the chair of the Bangalore section has done a fantastic job, so I'll cut my time on that. And then I'll talk about, in the second part, some important but unpleasant issues relating to AI. And particularly, these are the problems. And so this may be useful for the students who are going to be the future leaders in science and technology. In this era of whether you call it machine learning, AI, computational intelligence, it's needless to overemphasize that any activities that can energize the students into CI related activities or AI related activities is always welcome. And I am thankful to the NITK for forming this chapter. Now, question is, what is CI and what is CIS? Now, my previous speaker has done, as I mentioned, is a good job of defining CI and some activities of CIS also. I'll also spend some time on that, but maybe the perspective would be a little bit different. And there is one question which I have faced in many occasions. People ask me, what is the difference between CI and AI? What is the relation of CI and AI? I'll try to touch upon this also. And finally, I will summarize the activities of CIS in 5 Ws: why, where, what, who, when. You will see what those means. Now, if you look at the CIS website, it defines computational intelligence as the theory, design, application, and development of biologically and linguistically motivated computational paradigm. So the key point here, any activity that falls under biologically or linguistically motivated or nature motivated, they will become under the umbrella of computational intelligence. And of course, as you already know by now, the 3 major pillars are: first is neural network, which tries to model the way biological neuron works. But I must tell you that we are far from mimicking the biological neurons. There's a lot of opportunity to work. You will see how the things are moving now and where the problems are. Then the second pillar is fuzzy sets and systems. You already know that this can model uncertainty, linguistic imprecision, vagueness. So this is a tool for modeling uncertainty. It is also a tool for problem solving. Now, most of the books, if you look at, you will find that fuzzy sets is referred to as a tool for defining or modeling linguistic imprecision or vagueness. But actually, this can also model another type of uncertainty called non-specificity, which is not very common in the literature, but it's fantastic in doing that also. The third major pillar is evolutionary computation, which essentially or primarily deals with optimization problem, where the optimization problem is not well defined, not differentiable, very large scale optimization problem. And this optimization problem, the steps are in line with biological evolutions, like we use concepts like selection, crossover, mutation. And there is one part of this evolutionary algorithm, which is called genetic programming, which does not optimize an objective function, but can find a program which can solve your problem. So which is significantly different from the others. In addition to that, swarm intelligence like ant colony optimization, particle swarm optimization, there are all kind of things. So that also falls under computational intelligence. So it's a very broad umbrella. Now, my personal view, I want to make it little more elaborate. Since it's computational intelligence, so I want to emphasize on the ability. So I prefer to say is the ability of biologically or linguistically, that is nature inspired computational systems, to solve problems and or to learn knowledge from data and or to augment its knowledge interacting with the environment, to develop human-like cognitive and reasoning skills, and or to make decisions. It's a fairly complex but inclusive definition. In summary, computational systems which are inspired by nature, which can solve problems, possibly complex problems, can learn knowledge from data, can interact with the environment to augment its knowledge, has human-like reasoning skill, and can make decisions. Now, if you ask me, do I need to have all these attributes to a system to call it computational intelligence? Certainly not. Now, but what AI is then. If you go by Oxford Dictionary, it says the study and development of computer system that can copy intelligent human behavior. So the emphasis is in copy, intelligent, and human behavior. If you go by Webster, there are two definitions. A branch of computer science dealing with simulations of intelligent behavior in computers, the capability of a machine to imitate intelligent human behavior. Again, the emphasis is on copying or imitating or simulating intelligent human behavior, where the word intelligent is quite loaded itself. And watch that these definitions are technology independent, they are very loaded. I can ask a question, are these definitions good enough in the present context? Well, I will not give an answer, you will answer it. Now, in this context, what is an AI system? I think it is important to look at the Turing test, which was proposed in 1950 by Alan Turing. Now, as you know, in Turing test, there are three players involved, one computer and the human, and there is a human evaluator. The evaluator cannot see which one is computer, which one is the human, but can interact with the computer and human, maybe through terminal or other mechanism. Now, if the evaluator fails to distinguish between the computer and the human, we say the computer wins. So is this good enough to call intelligent? Let me give you an exciting example. You all know that AlphaGo defeated the best Go player, KG, and AlphaGo made some unusual moves which normally human expert would not do. Should we call it intelligent? Well, yes and no also. The reason no, because it made the decision, but it cannot say why it has made those unusual moves. Now we can go to the other extreme end. Protein fold prediction. You know, protein is a sequence of amino acids. If you put into a solvent in nanoseconds time, it takes a funny shape, like this is one protein structure. And prediction of protein structure is very important. If you use physics-based method, then it's very time consuming. And no human being can predict the structure looking at the sequence. However, AlphaFold can do a fantastic job. So this is not mimicking human. So mimicking human, we cannot just say is the attribute for intelligent system. Sometimes it's beyond that, but of course, mimicking human is certainly a milestone. Then where do we stand? Can we really distinguish between AI and CA, or do we need to do it? Consider some of the very successful AI systems, for example, AlphaGo, self-driving car, Google Assistant. We all are excited about ChatGPT now, large-scale image classification. For all these successful AI systems, neural network like deep neural network, convolution, recurrent, transformer, they play key roles. So the drivers are the neural networks, and you already know neural network is a major pillar of CI. Evolutionary algorithms have been successfully used in designing video games, and it has been being used for finding neural architecture, even for large-scale models like transformer and many other applications. And EC is a major pillar of CI also. And the third point, AI systems has a lot of criticisms. In my second part of the talk, I will focus on that. But for critical applications, two most important criticism or limitations are lack of interpretability and explainability. Now, I will be spending more time on this later. Now, fuzzy approaches, which is another pillar of CI, can certainly help to achieve interpretability and explainability. For example, if I give you a neural network, you know the computations that is being done at every point or every node of the network, but you do not know really what the semantic of that computation is. But if you use a rule-based system, if I say if the body temperature is high and blood sugar level is low, then suffering from some disease. You know the computation, you understand what it means. So the fuzzy approaches can help. But are you very successful here compared to neural network? Not yet. So then what is the conclusion? Is CI the same as AI? Certainly not. Is CI is a subset of AI? Certainly not, because there are things in CI which is not AI. Is AI is a subset of CI? That is also not true, because for example, you have expert system which is not part of CI, but it is AI. So why bother with the terminology? I'm trying to avoid the problem now. Focus on getting better results. And if you look at the ground reality, as of now, the most successful AI is CI. And so this takes me to my first W. Why should you be us? Why should you join us? Well, why should you join us? Well, the reason is it's one of the most flourishing technologies. It is the backbone of many successful AI systems. So therefore, if you have interest in CI, or if you call it AI, CIS is your home. Join us if not done already. This is true for students, and this is true for other faculty members also. Now, there are more reasons to join us. Now, this has been very nicely summarized by the chair of the Bangalore section. I have some slides towards the end, but I may not focus on that. So what is CIS? Now, this is the leading scientific, technological, and professional association in computational intelligence. And you have already seen our field of interest, which is basically biologically and linguistically motivated computational paradigm. Our members work in all kind of areas: AI, neural net, fuzzy systems, cognitive development, etc. We provide the key technologies for deep learning, big data analysis, smart X technologies, and so on. Who are we? We are a big gang, about 8,000 scientists, engineers, professionals, distributed from all over the world, truly international body. These are some of the volunteers. I mean, there are plenty, it's just a snapshot. And how do you organize ourselves? This is important for you to know. If you join as a student, and if you want to really take your path through CIS, you can really reach to the president of CIS. The way it is organized, you can become the president also. So our activities are divided into 6 verticals, and each vertical is headed by a vice president. So we have technical activities. As the name says, it's clear what it can do. Members activities, this primarily focus on member-centric jobs like distinguished lecture program, young professional program, student travel grant, women in computational intelligence, etc. Industrial and government activities, this is a recently created verticals emphasizing on industry and government needs. Education, CIS respects education a lot, and we spend a lot of effort on education. So we have a lot of education materials for almost everybody, including pre-college, college, and so on. Publications, you will see we publish a fantastic set of journals in the area of CI or AI, if you call, and we also organize a large number of great conferences. Where are the CI's communities? It is distributed all over the world. Currently, we have more than 126 section chapters and student branch chapters. There are 12 technical committees, 99 task forces, and when you set up a committee, we try to ensure diversity, both in terms of geography, gender, all kind of things. And you already know, my previous speaker has mentioned what all things the chapters can do and what all supports you can get from the CIS, like distinguished travel support for distinguished lecture and so on. So I don't want to spend time on that. What do we publish? We publish fantastic transactions for neural network, fuzzy systems, evolutionary computing, emerging topics in CI, cognitive and developmental systems, games, and we recently started transactions on artificial intelligence. We have a magazine called Computational Intelligence, and you can look at the impact factor like transactions, neural networks, and learning systems has impact factor 14.25, the recent one. EC, evolutionary computation, has 16.49. So it clearly says we publish fantastic jobs to students. When you get a piece of research done, if you're looking for the best venue, we are there. We also publish a monthly newsletter and a book series. When do we meet? We meet in various conferences. I'll mention about only few. Our one of the premier event is called World Congress on Computational Intelligence, which is organized every alternate years, more specifically in the even years. Like 2024, there will be one. It's really under one umbrella. You have three major conferences. One is on evolutionary computation, one is on fuzzy systems, one is on neural networks. And in the odd years, these three conferences are held separately. Like in 2013, this conference on fuzzy systems was held in Hyderabad. I must mention, to be technically correct, that in odd years, the neural network conference is primarily organized by International Neural Network Society, and we are a technical co-sponsor of this. That's why it's called joint conference. This year, we have started a conference on AI, and we have another very big event called IEEE Symposium Series on Computational Intelligence, which is essentially a collection of number of mini conferences. And in 2018, this was held in Bangalore. So you see, India, we have been organizing these big events, and any one of you can probably propose to organize one of these events. It's our conference committee really always there to help you to formulate a good proposal. Now, why should you be us? I would not spend much time. You have already heard a lot, but I want to mention that if you are a member of CIS, you will get access to all the major CIS transactions, which are fully sponsored by CIS, like transactions on neural network and learning systems, transaction fuzzy systems, evolutionary computation, emerging topics in CI. You will get the e-letter, you will get the CI magazine, and of course, you can get student grants, summer training program, summer school you can organize, and many other things. So students, to build up your future, start from now. And if you have not joined already, please join our team. I tell you that you will be very happy as I am now. So with this, my business of CI and CIS is done. And now I will switch the topic to another, the second part, which is a few important but unpleasant issues relating to AI. They are unpleasant, but they give a lot of research problems to work on. Is my screen visible? Anyone, please?
Yes, sir.
Thank you. All right, so we all know that we have tremendous success of AIs in many, many areas, healthcare and all kind of areas. In fact, we have AI in religion also. In Japan, in Kyoto, we have a robot priest called Minder in Kodaiji Temple. We have this excitement about Chat GPT now. I can spend a lot of time on this. It's very interesting, whether good or bad, but that's for some other time. But so we should be very happy about the present state of AI. Well, true, but there are certain issues which we need to be careful about. Now, AI is great, but it can be easily fooled, of course, in some context. I request you to look at these two pictures for some time. Now, even if I give you 1 hour, I don't think human being would be able to make any distinction between these two pictures. However, if you give it to this Google Net, The first picture is classified as a panda with confidence 57.7%. Second one is classified as a gibbon with confidence almost 100%. Now, you would expect that the second classification is with almost 100%. That's the correct classification. But in fact, it is not. It's the wrong classification. And what are the differences between the two images? Some imperceptible random noise has been added. So it's easy to create many such examples. There are many papers on this. The whole point is it's good, but you have to be careful. Now, I'm going to give you, in some sense, my personal view about these issues. And some of you may not agree with this. If so, it's fine. The first, I begin with lack of transparency. And this is an issue which is not really related to the technology, in my view, but it's related to the data, how the data are collected, what data are used. Like, you give me a medical system for diagnosing, say, pneumonia, whether it's caused by COVID or by something else, or influenza, and we have no idea how the system was trained, what kind of data it used. Did it use data from another country? Was the data labeled by crowdsourcing? Was the gold standard followed while labeling the data, like using three doctors to say, okay, here it is? When they agree, then this is the correct one. Most of the AI systems, you don't have it, and in every country there are task forces working on it to enforce certain level of transparency. Lack of interpretability, I have already mentioned here. Here, what I'm trying to say is, you have the AI system, whether it's a neural network or fuzzy systems, you know the computations that is being done at every node, but you do not know what is its associated semantics. What does it imply in terms of meaning? That's lack of interpretability of the model. And currently people are working on designing small interpretable models and then combining them to form bigger models and so on. But it's a long way to go. Lack of explainability. I would not be happy if a system, AI system, comes and tells me you have cancer without giving any explanation. And most of the AI systems can make a good job of decision making, but cannot explain why the decision was arrived at. Now, a lot of research is going on, and most of them are post hoc analysis that after you make a decision, you try to get a local interpretable model or something like that. But it's a long way to go. Lack of trustworthiness. The word trustworthy is very heavy. Under this word, you can probably bring everything, but I want to include only two aspects. What I want to say is that my system should be accurate, and it should have the capability to say, I do not know, in appropriate condition. What I mean is, you have trained the system to distinguish between cows and dogs, and you bring a goat and it says it's a cow. That's dangerous. It should not make decision under that circumstances. And most of the AI systems cannot do that. It's a very difficult problem. Very few people are working. In our group, we have done some work, but it's a miles to go. Lack of rational emphasis on data. Now, what is the tendency? More data, large system, and we are in a better position, as if data say all, which is not the case. Look at this picture. A baby is touching a burning candle. How many times do you think the baby need to do this experiment uh, to so that after that n times he or she would not touch it? I believe one or twice. So biological knowledge, the domain knowledge, incorporation of that while designing AI system is very, very important. And now some of the AI researchers are talking about physics inspired AI or physics incorporated into AI system and biology inspired AI. I'll focus on this biology part a little bit more. Lack of fairness. Now, often this AI system makes decisions and the decisions are not fair, and we do not know whether it is fair or not unless we really do specific analysis. I'll give one example and you will see how dangerous this could be. Lack of adequate emphasis on sustainability. This is also very, very important. AI solutions, AI systems should be sustainable. I'll spend little more time on this. Lack of emphasis on the principle of parsimony. Earlier, we used to consider that if a simple system can explain the problem, can make the decision, that is the better solution. But now nobody cares about that. Bigger the better. Lack of biological plausibility. Now, this is an issue I'll spend little more time in the next few minutes. So these are the four things that I will elaborate little bit. They're all heavily loaded, deep-rooted issues, but I'll make it little more clear. Now, lack of fairness. This is an incidence which really happened. Now, what is that? Judiciary and police often use software to assess whether a criminal defendant has a chance of doing the offense again, chance of being reoffender. Compass is one such tool which is being used for this purpose. Now, a detailed analysis of the performance of Compass revealed something very shocking. What was that? Black defendants who did not reoffend over 2 years, they were 48% times misclassified as having higher risk. That means the court would put them into jail. While for the white counterpart, it was only 23%. On the other hand, white defendants who actually reoffended within the next 2 years were classified having low risk 48% of the times, while this percentage was only 20 for the black reoffenders. See how dangerous, how biased, how unfair this system is towards the black defendants. These are called group unfairness. There are many other kind of unfairness. So what I'm saying is this is a very important issues, and students, you can also take this problem. There are many papers on this, various approaches, various definitions. And this lack of fairness can be for many reasons. One could be imbalanced distribution of data over classes, which is very well studied, gender imbalance within between classes, variation of age distribution, biased distribution of height. For example, I have an AI system again for distinguishing COVID related pneumonia versus say influenza related pneumonia, and the system was designed using X-ray images from a country where the people are having taller heights. I don't want to mention the name of the country, and then that is being used in our country where the average height is less. We'll be in trouble. Sensitivity of attributes to the decision making system, and most of the time the relevant information may not be available also. Like if you had transparency about the data, how this was labeled, you could have you could have probably caught that there is a possibility of unfairness. In addition to that, I'll consider or discuss a completely different type of unfairness, which is also related to sustainability. And we all, when I say we all, mean those who are in India, for example, is suffering from that. Now, lack of adequate emphasis on sustainability. Here I'll mention about two facets of sustainability. One is the AI provided solution should be sustainable. For example, to enhance crop yields, if we use too much of nitrogen fertilizer or too much groundwater or too much pesticide, that's not good. So AI provided solution must take into account the environment. Similarly, yield maximization may not be a good objective unless we take into account constraints like demand, storage capacity, delivery change, even weather condition. The other facet is the AI machine or the architecture or the algorithm should have less carbon footprints. You might be wondering, is this really important? We all keep our laptop on 24 hours, 365 days. Why he is talking about this? Well, because of Chat GPT, I'm sure all of you know of GPT. GPT-3 is one version of this GPT, Generative Pre-trained Transformer, which has 175 billion parameters. Now, it's not too big in today's world, and it can do all kind of interesting things that's not relevant now. But the carbon footprint for training this model is equivalent to 552 metric tons of carbon dioxide. Is it big? Is it bad enough? Well, this is roughly the carbon dioxide emission by 120 passenger car in a year in the US. You know how frequently US people use cars. So 120 car for 1 year. That's the carbon footprint of training this system. So you can imagine what would be for some of this 540 billion system. And things are really driven by kind of a weird principle. Bigger the better, bigger architecture, bigger data set. Now look at this picture. You can see there are systems, these are all language models only. And here I have summary up to August 2022. And we have model with 540 billion free parameters. It's going in a crazy manner. It seems there is a competition to scale up, increase complexity, increase model size, increase data size. There is a belief that scaling is all that matters. And this indirectly says data say all. It's dangerous. If you look at this view graph here, how it is going up. Now, GPT-4, there was a prediction this will have 100 trillion free variables. I do not know actually how much it is. It has come out. I tried to look for it. I couldn't find it. But human brain has 60 trillion. So it's dangerous. Now, what can it do? This can have tremendous carbon footprint, and this leads to another kind of unfairness affecting all of us. What is that? Think of how many of us would be able to train a system with 540 billions of free parameter. My institute, we cannot. Absolutely, period. Most of the, I don't know which university institute in India can do it. So what we end up doing, we will use their pre-trained model, adapt to our context, and we make small steps. Other alternative for us is we have to think about in a revolutionary manner, probably exploiting brain science. People have forgotten the principle of parsimony. Now, there is a danger behind this. Now, there are published paper, I forgot to include the reference, where you have a convolutional neural network which you can train using a data set where the labels are randomly permuted, and you get 100% training accuracy, but the test accuracy is just random. And this is such an important principle. I want to take the help to emphasize to the students. I want to take the help of two renowned scientists, all-time great scientists, Albert Einstein and Sir Isaac Newton. Uh, Einstein said, make everything as simple as possible, but not simpler. That means you should make it simple enough so that it works, but don't oversimplify. I'm not a genius. I'm just curious. I ask many questions. And when the answer is simple, then God is answering. Nothing can be stronger than this. Now, Sir Isaac Newton, about, again, further, if you go back to 50 years, he said, nature is pleased with simplicity and nature is no dummy. So you can see that these are not written for designing intelligent systems, but in my view, it says all. But somehow nobody cares about it. Now, in my view, the AI research in some sense started in 1943 when he first defined the computational neuron by McLuhan Pitts. This was a true inspiration from the brain. But today, are we giving adequate emphasis on the brain? Well, so far not, but things are changing. In my view, brain is probably the most complex thing in the known world with more unknowns than known. But we know quite a bit now, which can help us to design intelligent system. I will try to give an example that we did in our lab. Now, I must also mention this may not be relevant for all systems. Like for the protein fold prediction, this biological inspiration may not work. And this inspiration can be taken at two different levels. One is at a low level or neuronal level, how the brain functions. And second is at a higher level, the way human beings reasons or behave, like fuzzy reasoning. Now, I'm very happy that in the recent past, some of the prominent researchers in AI, they have started acknowledging the fact that the brain, inspiration from the brain is important. In fact, Bengio and his team, they wrote a paper with the title, Deep Learning Needs a Prefrontal Cortex. So this is very, very important. And for the students and young researchers, this is a way to go, but it's difficult. Even borrowing simple knowledge from the brain science can help. How? I'll take 2-3 more minutes. I know I crossed my limit, but I cannot resist myself for the students, keeping the students in mind. So here we are trying to get some inspiration from cat's visual cortex. I'll mention about the experiment. So the cat is sitting in front of the computer monitor, and drifting square wave gratings were presented onto the monitor at different directions, 45-degree, 90-degree, 225-degree, so on. Like these are the square wave gratings, and they were drifted on the screen like this, 45-degree, and maybe this is 225 or whatever it is. So it's 8 different angular rotations separated by 45-degree. And then what the experiment is, each orientation was presented sequentially and it was repeated 5 to 10 times. And then images of the visual cortex at 3 different levels were taken by very powerful 2-photon microscope. And what can you expect to observe? You will be surprised what was observed. This is what is observed. When the gratings were rotated at a 45-degree angle, a spatial cluster of neurons got activated. And when the opposite direction, that is 225-degree gratings were rotated 225 degrees, another cluster of neurons got activated. They are distinct, separate, as if there is a boundary. And more surprisingly and interestingly, along this hypothetical boundary, there are neurons which got activated both for 225 and 45. So as if it forms a functional microarchitecture like a classifier. There's a boundary, and near the boundary you make mistakes. You say it's both red and green, and as you go away from the boundary, you are either green or red. Amazing. So the question is, can we borrow this concept to design a multi-layer perceptron so that it's little more comprehensible? Okay, now I'm going to finish it in 2 minutes. I'm certain it's very difficult to pick up this. Don't worry, just try to get a feel of it. And first time equations will come here. So this is a layered architecture. Between layer, there are complete connections. This is my input layer. In the first hidden layer, neurons are arranged in a rectangular array or square array, doesn't matter. And so if we have M cross N neurons for the MLP part, this we call self-organizing map multi-layer perceptron layer, where we have neurons for both a self-organizing map network and a multi-layer perceptron network. in same number. So for if there are m cross n neurons for the self-organizing map, we have m cross n neurons for the multilayer perceptron, and there is a 1-1 association. That means corresponding to every self-organizing map neuron, there is a multilayer perceptron neuron. And how do the processing goes on? The multilayer perceptron neuron does what it should do, like it computes weighted sum of the inputs and apply a sigmoidal function. Self-organizing map neuron does what it is supposed to do, computes the similarity of the input with its associated weight vector. If the similarity is high, it produces an output close to 1, otherwise output goes to a very low value. So very simple. And in the next layer we call integration layer, where what we do is very simple. We take the product of the corresponding neurons of MLP and SOM. It's easy to see that if the SOM gives a 0 output, then that MLP output will not go at the higher level. After this, we can have one or more number of hidden layers, and they will behave like ordinary multi-layer perceptron. And we have two phases of training. In the first phase of training, both SOM and MLP weights are updated using the usual formula. You don't have to worry about that. When you learn it, you will learn it. And in phase 2, we just refine the multi-layer perceptron, because finally it is going to be a classifier. Now, what can it give, this bio-inspired MLP? Now, my first experiment is using an ordinary MLP, which also has a rectangular array of neuron in the first hidden layer. We have taken the MNIST dataset. This is a numeral dataset. We consider 0, 1, 7, and 8. Why? Because 1 and 7 may confuse, 0 and 8 may confuse. So we wanted to see how this network can help. So if we now plot the average test output of the hidden layer nodes for each class, for 0 we get this picture, for 1 we get this picture, 8 we get this, and 7 we get this. Could you see any pattern? Absolutely not. But if we use the new network, what we see is for 0, we get a spatial cluster of neurons activated. For 1, another spatial cluster of neurons activated. For 8, yet another spatial cluster of neurons activated. For 7, another spatial cluster of neurons activated. And if you look at these 4 images together, they look like mutually exclusive. That is fantastic. It gives some understandability of what goes on there. So you can see simple inspiration at a macro level. We did not take into account how the biological neuron actually works. We just made use of the observation. And this has led to a useful network. That's all. I am done. So friends, you should be happy with the present state of AI. Yes, but with the caveat, there are many issues when you confront with an AI system. Make sure that some of these are addressed. And in my view, inspiration from the brain may help in many cases. And who will take up the challenge? Young students and researchers should, and they are the best person for this. Thank you very much. Sorry, how to,
Thank you so much, sir, for the informational talk. Uh, I'll just, I hope I'm audible. Yeah, I'll take a second to introduce the executive committee of the CIS student chapter here at NITK. Our faculty advisor is Professor Annappa B. He is not here today, but he is our faculty advisor. The CIS chair is Siddharth Lanka. He is the CIS chair for the current year. I am the CIS vice chair, and Nishant Nayak. I'm the CIS vice chair for the year. The CIS secretaries are Shweta and Vaishali. So, yeah. Yeah, thank you to Shweta and Mashali for reaching out to the speakers and getting the speakers for this event. We will be following this up now with the workshop by Harish Kundu. So yeah, thank you again to the speakers who have come and given us their wisdom and knowledge for this event. Thank you so much.
Yeah. Uh, Hopefully, I'm audible. So, first of all, I would like to thank our speakers who joined us today. They actually gave very informative talks, and a lot of it actually really overlapped with my talk as well. So it's like a sort of a recap, and it's a good recap. So anyway, so let's start off. So the topic for today is called generative adversarial networks. So you must have seen this word adversarial before in Nikhil's talk, and it's actually an up and coming field of neural networks that has been implemented. So let's move on. Right. So before I go on to actually discussing what GANs are, as it abbreviated, I would like to show you some really cool examples of what they're capable of. So recently, just last month, Spotify released a notice called Spotify AI DJ. So it's like a new product feature of theirs. So what is Spotify AI DJ? It's sort of like this AI app that's there in your Spotify. So as you're playing music, it will also constantly stop the music and then speak like a radio presenter. So as you're listening to the radio in the car, you know how radio jockeys often mention a few things. They're like, "Hey, hi, what's up? This is the temperature today, and this is the song I want to play." So that's like the sort of thing that Spotify has also implemented, and they make a personalized playlist for you, and it's way smarter than the current playlist. So I think this will be coming out sometime in the next month. So that's very exciting. Apart from this, we have text generation. So a lot of you must have seen ChatGPT, which is blowing up right now, and that is also a type of generative AI. It need not be done by GANs, but this is overall class called generative AI. Next, we have image synthesis and deepfakes. So this is also like one of the issues of AI. You could say deepfakes, but nevertheless, it's still very exciting to see what we can achieve. Next, we have things like voice cloning, which is one of my personal interests as well, where you can actually clone your own voice to sound like somebody else's. So if you want to sound like Donald Trump, you could take your voice samples and his voice samples, and you can sort of convert your voice to his voice, which is also very exciting. So I'll just show you a few examples here. Right. So this is like a website called GANDissect, and here they essentially talk about GANs is like a little deeper insight. But what I would like to show you here is you can do really cool things on this website. So for example, here as you can see a picture, there's a picture of trees here, right? You could add trees or you could remove trees. So if I just hover over that, it just add trees automatically, and you can see how realistic
Go ahead.
Same thing happened last time also.
It's working.
This seems to be a projected issue. as we wait for it to load up, we'll actually go ahead with applying it. So, for example, I can choose something like tree, and I can just hover over this image, and so let's say I just do that, and then it will print trees in the areas where I just selected it. So, we can try something here as well. And wherever we draw over, it will just just print a tree there. And I can go to door, and then I can maybe put a door on this building here, and then it will go ahead and then draw that for me. That just appeared right now. So what about a dome? Maybe I'm going to convert this house to a dome and just do that. And then, so a dome should pop up. It's always not accurate, but it's pretty surreal to see what sort of results this piece of software could achieve. So how exactly do they do this? That's something that we have to know. Right. So coming to the introduction, this all comes under a huge class called Generative AI. So ChatGPT is an example of that. Where instead of telling whether a picture belongs to a certain class, right? So you would say whether it belongs to a cat or a dog class. Here you're generating images or you're generating data samples. So those data samples can be images, audio samples, or anything of that sort. So that class of machine learning is called as generative AI. And GANs are an example of that, along with some other things that we'll touch upon later. So this is something that's really up and coming and it's a very exciting field. And the future of AI will probably be in generative AI because now that discriminative AI is sort of hit its peak. So this is what we will expect in the future and this is what will carry AI forward. So, like I mentioned, there's a difference between generative models and discriminative models. So, generative models, like I said, can create new data samples, but discriminative models will discriminate between data samples. So, if I give you, let's say, an audio sample, you will tell me whether it belongs to a male voice or a female voice. That's discriminated, you're differentiating. But generative, you're generating. So another way to think about this is discriminative models more mathematically, it will tell you what's the probability of a class Y given X. So given a data sample X, what is a class Y is what discriminative models tell you. But generative models are more, they are creating the probability of P of X and Y. So they are creating both features and the classes that they belong to. So it's P of X and Y, but discriminative models is a P of Y given X. Right? So it's much harder to do generative models than discriminative models because it's very difficult for you to figure out what the relationship between features. It's easy to tell what's the difference, but we don't know what the relationship is. Right, so you have many different kinds of generative AI. You have autoencoders, you have GANs, which is our topic today, and autoregressive models. I won't go into the other two, but you should know that there are many other ways of generating new samples. It was created by Ian Goodfellow. In Nikhil sir's presentation, you could see that one of the authors was Ian Goodfellow. He and his colleagues created GANs in 2014. And one of the founders of, one of the pioneers of the convolutional neural networks actually termed the creation of